Good morning, guys. Welcome to the session. Today we'll be continuing our discussion on differential equations. So in the first part of differential equation, we have discussed about the basics, the first order and first degree differential equations. Today in this lecture, we'll be covering second order differential equations. Okay, just hold on a moment. This lecture will be covering second order differential equations. Okay, so everything is all right. We can start. Okay, so first of all, let's start with the general form, linear second order differential equation. Look, in this differential equation, we are only considering the linear differential equation. Non-linear is not there for the time being. So, what is the general form of this linear second order differential equation? You all know about it, and most of the question come from this second order differential equation only. Sometimes few questions come from the first order differential equation, but most of the time you get questions from second order differential equation. So if I write the most general form of the linear second order differential equation, you can write it in this way: d square y by dx square plus p of x dy dx plus q of x times y, this is equals to, let's say, some function f of x. Now in shorthand notation you can also write it in this way: y double prime plus p of x y prime plus q of x y prime, y, this is equals to f of x. So this is the general form of second order differential equation. Now let's say both equations are same. This equation 1 is said to be, look, it will be called as homogeneous if the function on the right hand side f of x is 0, and it will be called non-homogeneous if f of x is not equals to 0. It may be some exponential function, some sinusoidal functions, some polynomial function, or anything else, right? Now if this is this equation 1, it is a second order differential equation, right? Second order differential equation. So what we can expect? We will expect two linearly independent solution, y1 and y2. These are the two linearly independent solution, two linearly independent solutions. In the first order differential equation we got only one solution, but in second order differential equation we will get minimum two linearly independent solutions. Okay, now look, you can get more than two solutions, but those will not be linear, those will not be linearly independent. Linearly independent, two solutions, and there is a theorem regarding this, fundamental theorem of homogeneous differential equation. So what you can write, if let's say there is a theorem based on this, look, if let's say y1 of x and y2 of x be the two linearly independent. Okay, remember this term, linearly independent means you cannot express y1 in terms of y2. So y1x, y2x be the two linearly independent solutions of the homogeneous differential equation. Homogeneous means, you know, homogeneous means this f of x equals to 0. Homogeneous differential equations. For your convenience, you can also write the form. It will be p y double prime plus p of x y prime plus q of x into y. Homogeneous I am calling means f of x equals to 0. If y1x, y2x be the two linearly independent solutions of the homogeneous differential equation, then the general solution of, let's say, equation 1 is given by y is equals to a times y1 plus b times y2. This is, we are taking the linear combinations of the two independent solutions. So y will also be solution, means if you put y in the differential equation, it will satisfy for homogeneous differential equation. That is, y will also be a solution. Is that clear? Now, there is a term called Wronskian regarding the two solutions y1 and y2. So, what do you understand by Wronskian? Wronskian of the differential equation. Very simple definition is there, mathematical definition actually. What do you understand by the Wronskian of the differential equation? Let's say if y1x and y2x be the solutions of the differential equations, y1x and y2x be the solution of the, let's specify what kind of solution, whose solution is this, y1x and y2x be the solutions of the second order linear second order homogeneous, okay, f of x equals to 0, linear second order homogeneous differential equation. Then the Wronskian of the differential equation is defined as, very simple. How do you define it? Wronskian is a function of y1, y2, x. So in general, we write Wronskian as a function of x. This is equals to, you have to find out the determinant. y1 of x, you will write y1 of x, one solution, y2 of x, and just below you will write the derivative y1 prime of x, y2 prime of x. Okay, very simple. So you can, if you just write it in this way, y1 y2 prime minus y2 y1 prime. Now why Wronskian is important? Wronskian gives you a very important information regarding the nature of the solution. Whatever solution you get, let's say if you get the Wronskian equals to 0, it shows that the two solutions which you have taken, y1x and y2x, they are linearly dependent. Okay, y1x and y2x are linearly dependent. 0 means dependent. Okay, remember this thing, don't get confused with the independent thing. Non-zero means y1x and y2x are linearly independent. Clear? Now there is a very important theorem on this Wronskian, that is called Abel's theorem. Abel's theorem, what it does, if you know the Wronskian value, as you can see it is a function of x. So if you know the value of the Wronskian at some particular value of x, you can find out the value of Wronskian at another point or another x. Okay, so the value of the Wronskian, at different values of x can be related by the following relation. What is that relation? Let me just write it for you. Wronskian at x is equals to, let's say, x1, you can consider it in this way. This is the line for x. Okay, this is the line for x. Now somehow you know the value here, let's say at x equals to x naught. You can find out the value at some other point, x1 may be left or right anywhere. So w at x equals to x1 will be w at x equals to x naught. This is the initial point where you know the value of the Wronskian, exponential minus integration x naught to x1 p of x dx. P of x is what? P of x is the coefficient of dy dx. Okay, now this formula is looking very much like the integrating factor, right? But in integrating factor, the difference is, in integrating factor there is no negative, but in this Wronskian formula negative sign is there. Okay, in this way you can remember this. A very important formula. Sometimes it may be given that one of the two solutions you already know, One of the two solutions will be given to you, Wronskian will be given to you, and you may be asked what is the second solution. Is it clear till now? Let me know. Okay, let's go and solve this problem. Came in December 2011. Let x1t, x2t be the two linearly independent solutions of the differential equation given by this, and let w of t is this. Now, it is not explicitly telling you that wt is the Wronskian, but it has defined, and from the definition you can see that is x1 x2 prime minus x2 x1 prime. So this is nothing but the Wronskian, right? Wronskian. One solution is x1, another solution is x2, isn't it? The value of the Wronskian at x t equals to 0 equals to 1, then what is the value of the Wronskian at t equals to 1? So they have just changed here. X is what? X is the dependent variable, na? Dependent variable, and this t is now the independent variable. So in your question paper, sometimes examiner intentionally will change the notation, usual notation, but if you are clear with your concept, then you will not get confused, otherwise you will get confused. So let me know the answer in the comment section quickly. This will not take much time. I think you can solve it in 40-45 seconds. It should not take more than that. Harani, Deep, has you come? You people, what you do? You people should give attendance so that I can track who all are attending the lectures regularly. Okay. You have to be regular with the class. If you attend the classes regularly, if you revise regularly, then you will get the best result. And if you pile up things, that will not be good for you. D you are getting very well. Let's see whether we get D or not. So this is the differential equation given to you, and from this we can say that P is equals to, look, no, we will not write P of x. Now you should write P of t, right? This is equals to 2, and Q of t is equals to f of t. So by using Abel's theorem, we can write W at this point t is equals to W at, let's say, t naught initial point, e to the power minus t naught to t p of t dt. This will be the formula. So W and t is equals to 1, W at t equals to 0, e to the power minus 0 to 1, p of t is 2 dt. So W of 0 is 1, so e to the power minus dt, so 2t. Okay. 2t 0 to 1. So this is e to the power minus 2, that is 1 upon e square. Option D. Okay, now let's move on to the next question. Try doing this. Let y1, y2 be the two solutions of the differential equations given by this, where qx is an unknown but continuous function of x. Wx denotes the Wronskian of y1, y2. The value of y1, value of Wronskian at x equals to 0 is given, and if one of the solutions y1 is equals to the minus 3x, then the differential equation satisfied by the other solution y2 is. So you can do it. Simple question. Give it a try. You should be solving this question in 1 minute. Are you able to do this problem? What is p of x here? Minus 2. Okay. Here what is p of x? Minus 2. And what is given? First write those things which are given. Wronskian at x equals to 0 is equals to 2, y1 e to the power minus 3x given. So we can find out the expression of Wronskian. Wronskian of x, you know it. Let's say some constant e to the power minus integration minus 2 dx. When you do not want to specify the limits, you can write it in this way. Okay. Then by using initial conditions we can find out the value. So this is showing you, this is giving you c e to the power 2x. Okay. Now we can use the initial condition w at x equals to 0 equals to 2. It means c is equals to how much? 2, and w is equals to 2 e to the power 2x. Is that clear? Option D needs change. What change? By the definition of the Wronskian, we can write W of x, this is equals to the Wronskian of y1 y2. So y1 y2 y1 prime y2 prime. So y1 dy2 by dx minus y2 dy1 by dx. Okay, so we know the expression of Wronskian. This is 2e to the power 2x, 2e to the power 2x. y1 is e to the power minus 3x, e to the power minus 3x dy2 by dx minus y2 dy1 by dx is minus 3 e to the power minus 3x. Okay, so let's do some. Okay, if you just divide by e to the power minus 3x on both sides, what you get? This dy2 by dx minus minus plus 3y2, this is equals to 2 e to the power 2x plus 3x, so e to the power 5x. So option D is coming now. Deep. Look at this solution. If any doubts, you can let me know. Okay, let us now start talking about the solution. We have talked too much about y1 and y2. Now the question is how to find out y1 and y2. So you can give the heading, finding solutions. Finding solutions for the second order linear homogeneous. Firstly, we will cover homogeneous, then we will go for non-homogeneous. Differential equation. So what is the general form? If I am talking about homogeneous, the general form will become d square y upon dx square plus p or di dx plus q. The right hand side will be 0. P, Q, R constant coefficient, let's say. So let's take y is equals to c e to the power mx as a trial solution. Trial solution means we assume a solution, we just satisfy it by putting it into the actual differential equation. So if you put y equals to c to the power mx, then taking double derivative, this will give you c e to the power mx times m square plus p, one time derivative will 1 m will come and c to the power mx will remain, plus q equals to 0. That means The c to the power mx is, we have considered a non-zero solution. This is not a trivial solution. Zero solutions are called trivial solution. Non-zero means non-trivial. Remember this thing. This trivial word will appear many times. So m square plus pm plus q. For your convenience, I am just writing it here. Trivial, it means zero. Non-trivial, non-zero. This solution which you get, this solution is known as the auxiliary solution. Auxiliary equation corresponding to the differential equation. Now this is a quadratic equation, m square plus pm plus q. How many solutions, how many roots this equation has? If you consider this quadratic equation, how many roots will be there? So there will be 2 roots, m1, m2. Now depending on these 2 roots, the solutions will be decided. The roots may be real, the roots may be imaginary, the 2 roots may be equal, unequal, many things can be there, and depending on that we will get roughly 3 different cases. The first case being when m1 m2 are different and real. If m1 and m2 are real and distinct, distinct means different, then how the final step comes. Acha, you are talking about the previous solution. Okay, I did not check this one. This one we have got by dividing both sides with e to the power minus 3x. Got it, Harani? If you divide e to the power minus 3, this is gone, this is gone, and e to the power 2x by e to the power minus 3x, so e to the power 5x. Okay. Chalo. If m1 m2 are real and distinct, then the solution will be of the form y is equals to c1 e to the power m1x plus c2 e to the power m2x. c1 c2 are arbitrary constants. This is the first case. Let's go for case 2. If m1 and m2 are real and equal, means m1 m2 are equal, and let's say that is equals to m, then the solution will have the form y is equals to c1 plus c2x e to the power mx. Look guys, let me tell you one thing. Although I have provided the standard textbooks for all the subjects in your course folder. But let me tell you, if you only attend the classes, that will be sufficient as a study material. If you require to read anything from the book, I will tell you, or I will provide that PDF, that particular PDF. Otherwise, in the class itself, I will try to give you complete notes, okay, so that you don't need to go for any theory. Everything will be discussed in the class itself. That is why I write too much theory. Otherwise, I just can give you in the form of short notes. But I want you to just be dependent on this class lectures. Look, you have to limit our resources. If you go for multiple sources, then it will create confusion. So be focused and rely on limited resources and revise maximum. That will give you best outputs. Okay, let's go to case 3. If M1 and M2 are complex, conjugate of each other, complex conjugate to each other. Now here one thing needs to be understood, that when one of the roots is complex, the other root will be the complex conjugate. This is true every time. So if M1 and M2 are complex conjugate to each other, that is M1 equals to, let's say, alpha plus I beta, and M2, let's say, alpha minus I beta, the complex conjugate. Then the solution will be of the form y is equals to e to the power alpha x, this is the real part, multiplied by a cos beta x plus b sin beta x. So you need to remember this. If you practice few problems, it will get automatically stored in your memory. E to the power alpha x into a cos beta x plus b sin beta x. So these are the three cases which you should keep in mind in solving the linear second order homogeneous differential equations. Let's go for a problem if it is done. Look at this. Consider the differential equation given by this: if x equals to 0 at t equals to 0, x equals to 1, t equals to 1, then what is the value of x equals to 2? Value of x at t equals to 2. Do it quickly. I think you can solve it in 1 or 2 minutes, not more than that. You can write the auxiliary equation directly, right? Auxiliary equation corresponding to the differential equation. So as you can see, it is m square minus 3m plus 2 equals to 0. So we can write it as m minus 2 m square minus 2m minus m plus 2 m into m minus 2 minus 1 m minus 2. So m minus 2 times m minus 1 equals to 0. That gives us m is equals to 1 and 2. So these are real and distinct, the first case, and hence we can write the solution here. X is the solution, t is the independent variable, x of t, c1. So let's write c1 or a b in the form of a b. You can write a e to the power m1x, so you can take any as m1, any at m2, a to the power 2t plus p to the power t. Okay. Now what is given at x equals to 0, t equals to 0, sorry, at t equals to 0, x equals to 0. Given x at t equals to 0 equals to 0, that means a plus b equals to 0 or b is equals to minus a. B is equals to minus a, then x of t equals to a times e to the power 2t minus e to the power t. Another condition is given, two unknown, two initial conditions you require minimum, x equals to 1, t equals to 1. So what you can write, 1 a e square minus e times a is equals to 1 upon e square minus e. B you are getting, okay, let's check. Value of x at t equals to 2, x at t equals to 2. So a is 1 upon e square minus e to the power, t is 2, so e to the power 4 minus e square. So e to the power 4 minus e square is equals to e square whole square minus e whole square. So this is equals to e square plus e square minus e divided by e square minus e. So this 2 get cancelled, you get e square plus e in return, that is matching with option B. Okay. Simple question was there. Let's move on to the next question. Okay, do this one. The differential equation has the complete solution in terms of arbitrary constants a and b. You won't believe this question came in TFR. Such a simple problem came in TFR. Tell me the answer quickly. I think you can also solve it orally without using the pen and paper. You can solve it. but you have to be very careful while selecting the options. The options are really very close. सावधानी हटी दुर्घटना घटी. Okay. What answer are you getting? Why is it taking too much time? What is the auxiliary equation? M square minus 2m plus 1 equals to 0. So this is m minus 1 whole square equals to 0. That is the value of m is equals to 1 and 1. So this is real and equal. Option A, very good. So the solution y of x is equals to a plus bx e to the power x. So it is just written in an expanded form. Okay, so option A, very simple. Chalo, let me give you another problem if this is done. We are trying to cover all the cases, right? Solve the differential equation. D square y upon dx square plus 4 dy dx plus 5y equals to 0. बताओ. If you need option, let me create options. Let's say option A, e to the power x a sin x plus b cos x, e to the power minus 2x a sin x plus b cos x, e to the power minus 2x a cos bx a cos x plus b sin x, and option D, e to the power x a cos x plus b sin x. Chalo, I have created 4 options for you. Now you have to tell me which option is correct. C, let's see. Auxiliary equation m square plus 4m plus 5 equals to 0. We can use Sridhar formula. So minus b plus minus root over b square minus 4ac divided by 2a. So this is equals to minus 2 plus minus 2i. 2i or 2 is divided, so I. So one of the roots, okay, so we can write alpha is equals to minus 2 and beta is equals to 1. Therefore the solution is e to the power alpha x, so e to the power minus 2x, a cos beta x, beta is 1, plus b sin beta x, that is matching with option C. ठीक. So I hope you have understood all the three types. We have considered three types and we have also given you three problems based on that. Now let's consider the non-homogeneous solutions. So means the right hand side is not equals to 0. There may be some sinusoidal functions, there may be some exponential functions or some other algebraic functions may be there. So let's talk about this finding solutions for second order non-homogeneous differential equations. Give the heading quickly. The general form will be d square y by dx square plus p dy dx plus qy, this is equals to r of x. So f of x we are writing, let's say r of x for the time being, because f we will be utilizing at another place. Now this equation can be written as, let's say, d square plus p times d plus q times y is equals to r of x, where we can consider, let's say, d dx, this is the differential operator d square by dx square is the differential operator d square, and so on. And as you can see, this d square plus p of pd plus q, it is a function of d, so we can write f of d, capital D, and this y, this is equals to r of x. Now as you can see, y is equals to r of x by f of d. Now the complete solution of this differential equation, the complete solution of the differential equation let's say this is equation number 1. Complete solution of the equation 1 is given by the sum of number 1, that is called complementary function, complementary function, in short CF, and number 2, particular integral, in short PI. Now this complementary function is the same solution which you obtain from the homogeneous part, means whatever thing will be given on the right hand side, you will just ignore that, you will just equate it to 0, and whatever solution you get in the usual manner which we have discussed earlier, that will be the complementary function. This is the homogeneous part, actually this is the homogeneous part, homogeneous part of the solution. I should not write homogeneous part of the solution, just write homogeneous part. And this particular integral is only involving this non-homogeneous part, and it depends on the form of r of x. Okay. Instead of writing homogeneous part, you can write homogeneous solution, and hence we can write it in this way: y, that complete solution is y is equals to the sum of complementary function plus the particular integral. It is also written in this way: yh homogeneous part, y p particular integral. Now this homogeneous part we have already learned. Now let's talk about this particular integral. So there are some rules depending on the different forms of Rx. So let's summarize them. You can give the heading: rules to get particular integral. Rules to get particular integral pi. Number 1, let's say r of x is an exponential function e to the power ax. Then the particular integral will be, you see, y is equal f of d into y equals to r of x. So y equals to 1 upon f of d rx. You can also write it in the here. Y is equals to 1 upon f of d times rx. So rx is now e to the power x. So it is 1 upon f of d e to the power x. So this can be written as 1 upon f of a. So in place of d you will write a and e to the power x. Now there may be two cases here also. If this f of a becomes 0, then this function will be undefined or divergent. So you can say if f of a equals to 0, then the particular integral will be, you have to just multiply with x and you have to take a derivative, 1 by f of this, 1 by f of a prime of a e to the power ax. Now you can think that what if this a prime a also becomes 0. So again similar procedure you will do. If let's say f of a prime of a equals to 0, then the particular integral will be written as, you again multiply with x, so x and x square, 1 upon f double prime of a e to the power x. You can think of, okay, let me ask you, should we consider more higher order? Should we think that what if f double prime a equals to 0? Will it be 0 by any chance? Is there any possibility for the third case? Tell me, is there any possibility that we should consider the third case? What if f double prime equals to 0? Can that be 0? Yes or no? Think. Let's say Rx be a polynomial of x. Then the particular integral will be 1 upon f of d x to the power n. Then what you have to do, you have to expand 1 upon f of d in series. No, because it is a second order differential equation, so maximum it will go up to this, because this is a second order differential equation. So d square will be the maximum term, and d square when you take double derivative it will become constant. Third case, let us say if Rx is some cos or sine, both cases the formula is same, cos, either cos Ax or sin Ax, in both the case the formula will not be changed, same. Then the particular integral will be 1 upon f of d square. Look, this is little different. Every time we were placing f of d, but here it is f of d square sin x. So you have to put, instead of d square you have to put minus a square, not minus a whole square, it is minus a square. This will be a negative number, isn't it? 1 upon f of minus a square, not minus a of whole square. Remember this thing. Sin x or cos x, both is valid. Now it may happen that if, let us say, f of minus a square equals to 0, what will you do then? Then your particular integral will become, as usual, we will multiply with x and take the derivative at the denominator. So f prime of minus a square sin x. As we have already considered d square, so there will not be another case. Another one is left, fourth case, if the non-homogeneous part is, let us say, e to the power ax times some function f phi of x. In that case the particular integral will become 1 upon f of d e to the power ax phi x. So this exponential x can be taken to the left, exponential x, but it cost f of d to change to f of d plus a. Remember this thing, we are taking e to the power plus ax, and in the denominator it becoming f of d plus a, right, multiplied by phi of x. So the fourth case is does not generally come. Mostly the first three cases you see in your examination. Tell me, till now, is there any confusion or question? After this we will go for some problem. Okay, so solve this problem. Third one, okay. Let's say f of d, it is in this form, d square minus 5d plus 2 cos x, let's say cos 2x. For the time being, let's take a simpler case, d square minus 5, let's say. So what you gonna do, 1 upon, in place of d square you will write minus 2 square minus 5 times cos 2x. Okay, clear? We will be solving problem based on this, don't worry. So wherever you see d square, you will just place with minus a square, and you may left with some function involving d and all. So you can multiply with, let's say if you get, after doing this, let's say you are given such a function that you are getting in the denominator d minus 1, but you need d square to put this value of a square, right? So what you can do, you can multiply with d plus 1 divided by d plus 1, so then it will become d square minus 1, then you can put d square equals to minus a square. Okay, chalo, solve this first problem. Okay, do it quickly. We'll be back. B, yes, B will be the correct option. Homogeneous part you can solve. First, so to find out YH or complementary function, we have to do m square minus 3m plus 2 equals to 0, m minus 1, m minus 2 equals to 0, m is equals to 1, 2. Therefore, the complementary function or YH, whatever you write, C1 e to the power x, C2 e to the power 2x. Now, let us go for the particular integral. So, particular integral will be 1 upon d square minus 3d plus 2 e to the power 5x. So, d equals to 5 we put, so e to the power 5x divided by 5 square minus 3 times 5 plus 2. So, how much this? 12. And hence that complete solution, sum of complementary functions and particular integral, C1 e to the power x, C2 e to the power 2x, e to the power 5x by 12. Option B. Well, let's go to the next problem. Chalo, do this one quickly, dosto. The solution of the differential equation, this sine. Now the non-homogeneous parts involve sine to x. Quick, tell me the option. Guys, those who are not enrolled in the course, you can enroll, get yourself enrolled. The Independence Day offer is going on, so you can get at a very low price. You can join. Which option are you getting, guys? Let's go for the complementary function first. I'm not writing a auxiliary equation and all these things. M square minus m plus minus 2 equals to 0. M square minus 2m plus m minus 2 equals to 0. M minus 2, that is m plus 1, m minus 2 equals to 0. That gives you m is equals to minus 1 plus 2. Real and distinct. Real and distinct means we can write the complementary function as c1 e to the power minus x, c2 e to the power 2x. Let's go for the particular integral. Particular integral is 1 upon f of d, means d square minus d minus 2 e to the power, sorry sin दे रखा है ना, sin 2x, sin 2x, no issue. So in place here a is 2, so 1 upon d square is minus a square minus d minus 2 sin 2x. C you are getting? Yes, C will be the answer. What are you getting now? 1 upon, okay, let's take minus outside, minus 4 minus 2 minus 6 minus d, so d plus 6 sin 2x. Now you need d square to operate on sin, to operate for sin 2x, but d plus 6 is there, so we can take d minus 6 above. So in the below also d minus 6, if you multiply d plus 6, d minus 6 is d square minus 6 square. Can you write it? Now again we have d square equals to minus 2 square minus 36 sin 2x. Okay, so minus 40, minus minus plus 1 upon 40 d of d sin 2x minus 6 sin 2x. Okay, so 1 upon 40 sin 2x, d means derivative, so 2 cos 2x minus 6 sine 2x, and that makes, if you take 2 common, 1 by 20 cos 2x minus 3 sine 2x. That is matching with option C. Tell me guys if there is anything you are confused with. Let's go for the next problem, if it is understood. If anyone has any doubt, you can ask. And those who have done, you can start solving the next one. As you can see, sometimes it may not give you in this form d square y by dx square. Sometimes they directly give you in this form d cube plus 8 into y, because this d is universally accepted differential operator, okay, in mathematical physics. Chalo, do this problem. In our theory, 1 by d square means double integration, okay, that thing I need to tell you. Good question actually, Hirani. Okay, you can just add on here. One by d, it is equivalent to integration, okay. So 1 by d square means double integration, you can say, but generally this thing is used. 1 by d, it will be integration. Do this one. You did not get it. Let's say I am giving an example. If somehow you get 1 by d x plus e to the power x plus 2. So what is the meaning? X square by 2 e to the power x plus 2x. Now understood, Hirani? Sorry, Harani. If you consider the same problem on up here for d, it is 1 plus e to the power x plus 0. This problem, are you able to solve this problem, or are you finding it difficult? Okay, the third order derivative, okay. But that is not a problem. If you know about second order, third order also you can handle. Let me just solve it for you. Complementary function, now it will be m cube plus 8 equals to 0. So this is the a cube plus b cube formula, isn't it? M plus 2 m square minus 2m plus 4. I think you all of you remember this formula of a cube plus b cube, m a plus b into a square minus ab plus b square. From this we are getting m is equals to minus 2, and this is m square minus 2m plus 4. From this you will get two complex roots, 1 plus I root 3, this is one of the root, another root 1 minus I root 3. So what you can do, you can just simply write the complementary function for this root minus 2. What you going to write? C1 e to the power minus 2x plus, you consider like this two complex conjugate roots e to the power alpha x. From this you can say alpha is equals to 1 and beta is equals to root 3. So e to the power alpha x, so e to the power x. In C1 we have already taken, so next constant coefficient will be C2. Cos beta x, so cos root 3x plus next constant C4, sorry C1, C2, C3 sin root 3 x. Clear till now? Now it is a polynomial of x. So I have told you how to do, you have to expand it. So let's do this. So complementary function is done. Let's go for particular integral. Sorry guys. So particular integral will be 1 upon f of d is d cube plus 8, to be applied on x to the power 4 plus x square plus 1. Is this the thing? X to the power 4 plus 2x plus 1, sorry. So as I told you, you have to expand it in series. So you have to keep it in the form for expansion. Let's say 8, if you take common, 1 plus d cube by 8. So this is in the form of 1 by 1 plus x. So 1 upon 8, 1 plus d cube by 8. If you take it to the numerator, it becomes to the power minus 1. Clear? I hope everything is getting clear. Now if you expand this, look, if the maximum power of x is 4, how many order of differentiation you need to do? After fifth derivative, in the fifth derivative, everything will be 0. If you take one time derivative, the x to the power 4 will be x cube, second type derivative x cube will become x square, third time x square will become x, and fourth time x become 1, and fifth time constant derivative of constant will be 0. So although this will give you many infinite terms, but what are those terms which you will take? 1 minus d cube by 8, this is the second term, and if you consider the third term, what will be the power of d? D to the power 6 will come, means sixth derivative, and that will make everything 0. So we don't need to take this, we just need to take up to 2 terms. Understood? So this is 1 by 8, 1 times this, so x to the power 4 plus 2x plus 1. This is one thing, minus d cube by 8, so 1 by 8, d cube of this thing, d cube of x to the power 4 plus 2x plus 1. All other terms will be 0. So this is equals to 1 by 8 x to the power 4 plus 2x plus 1 minus 1 by 8. Now third time derivatives of x to the power 4, 4x cube. So 4x cube, देखो एक टाइम डेरिवेटिव लेगा 4x cube, नेक्स्ट 12x square, नेक्स्ट 24x, okay, plus this will be 0, this will be 0, one by 8 x to the power 4 plus 2x minus 3x, so minus x plus 1. And that is why the complete solution is written in this way: c1 e to the power minus 2x plus e to the power x, c2 cos root 3x plus c3 sin root 3x plus 1 upon 8 x to the power 4 minus x plus 1. And that is matching with option D, I guess. Understood, guys? If anyone has any doubt, you can ask. Let's go for another problem. Solve d square minus 2d plus 1 y x square e to the power 3x. The fourth case. Can you do this? Complementary function you write m square minus 2m plus 1 equals to 0. m minus 1 whole square equals to 0, m equals to 1 1, real and equal. That means the complementary function is equals to c1 plus c2x e to the power x. Let's talk about particular integral. Particular integral is 1 upon f of d e to the power 3x x square. So if you take okay, let's write it in a simplified version, d minus 1 whole square. So if you take this e to the power 3x towards the left, 1 upon f of d plus a, so d plus 3 minus 1 e to the power 3x we have already taken to the left, so only x square will come. Okay, so this is e to the power 3x by d plus 2 whole square x square. Now again, as we have x square polynomial, so we have to expand it in series. So what you get if you expand it? So if you take 2 common, so 1 upon 4 e to the power 3x and 1 plus d by 2 to the power minus 2 x square. That gives us 1 by 4 e to the power 3x, 1 minus 2 into d by 2, so d, next it will come n into n plus 1, so 3 by 4 d square, and next d to the power 4 will come, that will make x square to be 0, that is equals to e to the power 3x by 4 times x square d of x square, so minus 2x, 3 by 4 d square, so 3 by 4 into 2x, so 3 by 2x into 1, so 3 by 2 plus 3 by 2. So I am writing the solution here. The complementary function is c1 plus c2x e to the power x, and the particular integral e to the power 3x by 4 multiplied by x square minus 2x plus 3 by 2. Okay. So I think it is enough for today. This Cauchy-Euler differential equation we can do it tomorrow, otherwise it will be too much for you. Is that okay? So tomorrow we will be starting with Cauchy-Euler differential equation. That is the only thing I think left in differential equation. Then after that we will go for the special function. There is also differential equation, but it is given separately in the syllabus. 4 special functions are there, and hopefully tomorrow we will try to cover at least 1 or 2. Okay, so let's end the session here. Everybody, after ending the session, like the video, and if you are new to this channel, please subscribe the channel. Okay, don't forget to press the bell icon. Have a great day, guys. Bye bye. Take care. the step d plus 3 minus 1. As you can see, what was our fourth rule? E to the power ax phi x, if you have a form like this, 1 by f of d will become 1 of f of d plus a. Okay, and that is why we had here e to the power 3x. So we have taken e to the power 3x. Okay, here. So d becomes d plus 3 and minus 1 is a minus 1. F of d plus a. Part 1 we have two lot of integration. Please tell me, sir, how to solve this. Part 1, what are you talking about? I am not able to get it merely. Which part? Specify a little bit so that I can answer you. Or you can DM me on WhatsApp. Okay, you can also voice message me. You can send voice message on WhatsApp. Part 1 differential equation. For this problem, d square minus 2d plus 1 into y equals to 0. For this problem, if you are asking, this is the auxiliary equation, m square minus 2m plus 1. So m minus 1 whole square equals to 0. So you are getting two real and equal roots, 1 and 1. And as per the formula we have learned, where is that? Yes, if m1 m2 are real and equal, solution is c1 plus c2x e to the power mx. That is why c1 plus c2x e to the power m equals to 1 e to the power x. And for this one, 1 by d square minus 2d plus 1 d minus 1 whole square e to the power 3x multiplied by x square. Then we have used the fourth rule of particular integral, e to the power 2x we have taken left, so d becomes d plus a, so d plus 3. Then here we have taken 2 common, so it come out from the square as 4, and 1 plus d by 2 going to the numerator becoming 1 plus d by 2 to the power minus 2 x square, and just expanded and just wrote the solution as a sum of complementary function and particular integral c1 plus c2x e to the power x plus this thing. Now clear, or any other question? Last lecture Saturday. Oh. Okay, you can send me photos of the part which you are not able to understand. Okay, in the WhatsApp I will explain to you. I thought you are talking about this one. Chalo, bye bye, take care.